So in the previous video, we talked about how to write equation of a parallel line. In this video, I'm going to talk about how to write equation of a perpendicular line. So guys, again, I'm not going into a lot of details about the conceptual details about the perpendicular lines here, but we're going to talk about the key things, and then we're going to use the key information and the prior knowledge to actually write an equation of a perpendicular line. Okay, so there are again two key things for perpendicular lines. Number one is, which you can see here, the slope of one line is opposite reciprocal. So it will make more sense for us to understand what is opposite reciprocal once we actually look at that particular example. So the key thing is, and I have underlined it here, there's two things, there's opposite and there's reciprocal. So let me already tell you something about that. So the reciprocal has to do with you have a numerator and the denominator, so just kind of flipping it. So the numerator becomes the denominator and the denominator becomes the numerator. That is the reciprocal piece. And the opposite has to do with the sign. So if the initial slope is positive, the new slope would be negative, and the other way around. Okay. So two key things: opposite, reciprocal. And the other thing which we may not be using a lot when we write the equation, but that is something that is more important from a geometric point of view, which is the fact that the two perpendicular lines, they intersect at a 90-degree angle. Guys, keep in mind, the parallel and perpendicular lines are very important, not only from an algebraic point of view, they're also very important from a geometry and then the calculus point of view as well. So it is very important to actually know how to write the equation of the parallel and perpendicular lines. I mean, when I teach calculus, these lines show up all the time. So please pay attention to writing the equation of these two types. So I'm going to illustrate this by actually showing you an example. The equation is going to basically the same that we use for the parallel lines, but now we are going to write a perpendicular line. So the example is that now we want to write an equation of a line which is perpendicular. So I'm using this notation to show perpendicular to, and it is the same line, 4y minus x equal to 20. That's what we used in the previous case. So since we already used that one, so I decided to stay with the same thing. And we want to write this new equation perpendicular to this line, and that passes through the same point, 2 and negative 3. So I'm not again going to actually draw the whole visualization, but you can go ahead and draw it, and you can see basically you're now, instead of drawing parallel lines, you're drawing lines that are perpendicular. Okay. So let us look at the solution steps. Now again, what do we need first? First, we need to evaluate the slope of this given line. So let's go ahead and rewrite this line, 4y minus x equal to 20. We already know how to find the slope. Guys, if we want to find the slope of any given line which looks in this form, and this is sometimes also thought of as a standard form, okay, ax plus by equal to c. So it's like this, ax plus by equal to c. So in order to get the slope for this form, we want to transform this into the slope-intercept form. Guys, slope-intercept form is the nicest and the easiest and the most useful form of an equation of a line. So we know the slope-intercept form, which looks like y equal to mx plus b, and m is our slope. So in the previous video, we already actually transformed this, but let's go ahead and look at the steps one more time. Obviously, you want to get rid of the x first, so you add x to both sides. I have 4y equals to x plus 20. We cannot combine them, they're not like terms. And then we want to get rid of the 4 as well. So you divide both sides by 4, you divide this by 4, you got to divide each and every piece by 4. Be careful, don't forget to divide the 20 by 4 as well. You have to divide everything by 4. So 4's cross out, I have y equals to 1/4 x plus 5. This is my line 1. I'm going to call this line 1. And from this, for this line 1, what is my slope? So let us go ahead right here. The slope of this line can easily be identified, which is the coefficient of x. So let us call this slope m1, which is 1/4. So that is the slope of the given line, correct? Now we want to write the equation of a line which is perpendicular to this line. And what do we know about the slopes of perpendicular lines? They are opposite reciprocals. So what would be the opposite reciprocal of 1/4? Guys, there's two things, as I said prior. The reciprocal and the opposite. So reciprocal has to do with flipping the numerator and the denominator. So the reciprocal piece makes it 4/1. I mean, you can ignore the 1, it's in the denominator, so it does not matter. And then the next step is The one is the reciprocal piece and the other one is the opposite. And opposite, as I said earlier, has to do with the sign. So it is positive and it will change to a negative. Just change the sign. Guys, it is not too complicated if we remember two key things, opposite and reciprocal. Okay. So then the slope of the new line, which I like to call as m subscript 2, is -4. So we have the new slope of the line, which is going to be perpendicular to the given line L1. And we also have the point. And the point is 2, -3. Again, guys, at this point, it is just similar to what we have been doing in the previous videos. But let's go ahead and actually write the equation. Again, it would make sense to use the point slope form because we have a point and the slope. And let's go ahead and try to write that equation. So I'm going to label this as x1, this as y1, and the form is y minus y1 equals to m, x minus x1. And now I'm going to substitute the values. So it's going to look like y minus and -3. Obviously, we have to put it in parentheses. And the slope is -4. And then I have my x minus x1, which is x minus 2, right? Simplifying further, this is going to be y plus 3 again. Two negatives become positive, -4 and x minus 2. Guys, this is the equation of the line in the point slope form. And if we want to transform this into a slope-intercept form, I mean, it's not too difficult, we can do it. We simply have to distribute this -4, and then we may have to do one extra step to actually get y by itself, right? The whole idea of the slope-intercept form is to have it look like this form, which is y on the left-hand side and everything else on the right-hand side, okay? So it's y plus 3 equals to, distributing this -4 carefully, it's going to be -4x, and -4 times -2, negative times negative is positive, so it's going to be 4 times 2 is 8. We're almost there. You got to subtract 3 from both sides. Okay, let's go ahead and do that. And we have y equals to -4x because 3's will cross out, and 8 minus 3 is +5. Guys, this right here is the equation of the line. Let's call this L2, which is perpendicular to this line. So look at these two lines. Here the slope is 1/4. Here the slope is -4. And if you like to put that invisible 1, you can put it. So it is opposite reciprocals. And then the y-intercepts are the same, and sometimes they could be the same, but they don't have to be the same all the time. Okay, so guys, parallel and perpendicular is done. So in the next video probably we'll talk about some other types of equation of a line. Okay.